Okay, so we're back now, and we are in the last section of section 7.2, where we're going to take a look at maybe 2 to 3 division problems that are going to be worked out from beginning to end here, and let's see what the solutions of these look like. So, the first question we're going to go ahead and look at will be question number 68. So a lot of factoring to this, a lot of critical work to this. No, actually, let's not look at 68 yet. I'm not ready to take you there yet. That'll probably come in the next lesson once I introduce you guys to some more factoring. Let's go ahead and take a look at 71. So this is going to be x to the third minus 64 divided by x to the third plus 64. And this will be divided by the rational expression of x squared minus 16 divided by x squared minus 4x plus 16. All right, so I'm not going to go through all the steps of how all of the factoring are done here. I'm simply going to show the results of the factoring. But the first thing you have to remember to do when you're doing a question like this is you have to remember to make this a multiplication problem. So I'm going to write this as x to the third minus 64 over x to the third plus 64 times x to the second minus 4x plus 16 divided by or over x squared minus 16. So if we look at x squared minus 16, you should recognize pretty quickly that's the difference of perfect squares. And this factors into x plus 4 times x minus 4. Notice here I'm not devoting as much time to the techniques of factoring. I've spent some time on that already. I'm kind of going more to the answer. And if you need help with factoring again, that will be offered very soon. So we have x to the third minus 64, x to the third plus 64. This is the difference of perfect cubes. This is the sum of perfect cubes. So when I write the factors out, I'm going to have for this x minus 4 times x squared plus 16x, or excuse me, 4x plus 4x. Yeah, sorry guys, I'm just making a mistake here. X squared plus 4x plus 16. For the bottom one, for x to the third plus 64, that's going to be x plus 4 over, or times, x squared minus 4x plus 16. On the top, we have this, which doesn't factor, into x squared minus 4x plus 16. This here is a trinomial that doesn't factor. Doesn't matter. These trinomials are going to reduce after we factor the sum of perfect cubes. We have an x minus 4 that factors here as well. So we have on the top remaining x to the second plus 4x plus 16. And on the top we have x plus 4 times x plus 4. You can write it like this. Another way which you may also be required to express it, depending on what MyMathLab asks for, you may also be required to write this as x plus 4 squared. So both of these forms for me are perfectly acceptable. However, MyMathLab may ask for the answer written into this form. So just please be aware of that. Taking a look at a few of the questions which are just a little different perhaps. So I want you to be comfortable when you see questions written in this form. Let's take a look first at question 58. And it's written as so: x squared minus 5x minus 6 divided by x squared minus 1 over x plus 6. So we have a trinomial being divided by a rational expression. This question sometimes throws students off because we're not dividing a fraction by another fraction. We're just dividing something by a fraction. Well, to simplify this, go ahead and just put this all over 1. And that should look familiar and a lot more comfortable to people out there. And now I'm going to go ahead and rewrite the problem as a multiplication problem. So this will give me x squared minus 5x minus 6 over 1 times x plus 6 over x squared minus 1. Now that I have the problem simplified in a form that looks comfortable, I'm going to go ahead and see what factoring I can do. Just remember, make the problem multiplication before you factor. Well, 1 I can't do anything with. X plus 6 is in its simplest form. X squared minus 1, that is the difference of perfect squares, which I can write as x plus 1 and x minus 1. And then x squared minus 5x minus 6, I can write these factors. Two numbers that multiply to negative 6 and add to negative 5. Be careful of this one. This trips up students a lot. The only way you can get a product of negative 6 and a sum of negative 5 is with negative 6 and plus 1. A lot of students like to use 2 and 3, but the signs here have to be opposite. So be careful. So looking further into this now, we'll see that it appears the only thing that's going to reduce top to bottom is going to be x plus 1. And what we have left here is we have x minus 6 times x plus 6. And that's going to be over 1 times x plus 1. And because it's only 1, it won't affect the answer, so I don't have to worry about parentheses. So we write the answer in its simplest form here. Another problem which may throw students off is going to be the last one we're going to consider for today. And this is going to be question 70. This is going to be z to the second minus 2z plus 1 over z squared minus 1 divided by 4z squared minus z minus 3. So just like we did in the last question, we're going to go ahead and put a 1 underneath this. For this one, it's especially important because when we flip this, we have to ensure that the 1's going to be at the top, and then the polynomial of 4z to the second minus z minus 3 is going to be at the bottom now. So let's go ahead and do that first so we don't miss that step. And let's go here. So we have z to the second minus 2z plus 1 over z squared minus 1. Just to kind of separate that out. Well, when we look at doing some factoring, z squared minus 1 you can factor as z plus 1 times z minus 1. Z squared minus 2z plus 1 I can factor as z minus 1 times z minus 1. 4z to the third minus z minus 3. How do we get this for an answer? So we're going to take no, I don't think we'll do that this time, but I will visit this later. In fact, this will probably be something I even show in class. So I'm just going to kind of go for the answer on this one here. And I'm going to say that the one factor here is going to be 4z plus 3. And then the other factor is going to be z minus 1. I don't expect that you know how to do that. Now, some of you will know how to do it. Others are not going to. I will show this technique in class in a special type of factoring. This one I'm able to do in my head, but I promise that I will show this technique in class because the technique for doing this is among the more complicated techniques. But it requires learning another technique of actually a couple techniques of factoring first before you can go to this. but I don't want to miss this step. The long story short is you have to write the factors out. Once we do that, we see what factors are in common. We have z minus 1 here, z minus 1 here, and on the top all we have is 1. And at the bottom we have z plus 1 over 4z plus 3. This is the last question we're going to go over in this section. You will find maybe one question in your homework which contains some unusually difficult factoring. I will go over this type of factoring specifically in class, perhaps at a later time. I will also provide some examples for the video as well. In the meantime, I hope that you have learned a lot from this. Please be sure at the end of the video to add any comments about any questions you have, or if you learned this well, or if this was too simple, or if this was really challenging. And be sure to bring those questions to class so we can talk about them there and address them further. Thank you.